Hello everyone, my name is Phong Nguyen. I'm a PhD student from University of Oulu, Finland. This is the paper Free-Viewpoint RGB-D Human Performance Capture and Rendering. This is a collaboration work between me and my colleague at Meta Research Reality Lab in Sausalito, California. Let's get started. In this work, we present a generalizable human view synthesis method that renders novel views of a human from a sparse RGB-D image. In our setting, the camera is placed on the ground, looking up to the person, so it is quite challenging to render occluded region. Our goal here is to produce high fidelity and temporal consistent novel view. In this work, we propose using sphere-based rendering instead of using point-based rendering. When we render the sparse point cloud to the image plane, we often obtain a sparse image. Here, we treat each 3D point as a sphere with a learnable radius. Using the efficient sphere-based rendering and pulsar method, we obtain a much denser image, as you can see in the figure. Here, we explain our main pipeline. Our view synthesis network takes an input image and feed it to a feature extractor. We then use the extracted feature to learn the per pixel radius. Both the learned radius and the sparse depth are then utilized by the sphere-based renderer to obtain the denser target features. We then use a global context inpainting network to fill in the hole and obtain the foreground mask, the confidence mask, and the RGB color of the novel view. We use the common photometric losses, such as L2 and GAN loss, to train our network using the ground truth view. However, we found that a single view synthesis network cannot handle hard occluded regions. Therefore, we propose using an additional post-read input, such as a selfie photo, which include unoccluded region of the human. From the initially estimated novel views, we feed it to the IOV predictor. Our proposed HD IOV representation is so versatile in a way that it covers both cloth and hair of the human. We then warp the selfie photo to the novel view and then refine the current estimate to obtain the higher quality output. We train our method on the training set of the render people dataset. Here we show the additional qualitative result on the unseen synthetic human on the testing set of the render people dataset. Although our method has been trained on the purely synthetic data, but our method generalizes out of the box on the unseen real human. Here, we compare our method with other state-of-the-art methods, such as Looking Good and Sensing. Our method is able to render plausible and realistic novel view of a human and outperform both baseline. I personally like the high-quality logo that has been rendered on the t-shirt of the human. Here, we show a live demo of our approach. Our approach is not only fast, but also a generalizable human view synthesis. It runs at 30 FPS and produces a reasonably large novel view at the resolution of 512 and 512. We use the RTX 3080 Ti with tensor optimization for fast rendering. Here you can see that after synthesis, our novel view is much denser compared to the reprojected input points. In conclusion, we propose a real-time human view synthesis method for 3D augmented calling application. We handle the occluded region with an enhancer module that utilizes an additional selfie photo. Our method trained on synthetic data and work out of the box with real image from a 3D scanner. For more information, please visit our project page and see you in Tel Aviv at ECCV 2022. Thank you.